it seems a long time ago, and at the time we thought we'd done a pretty good job and broken some new ground. And of course now you look back at that vote, and probably both of them, and think and see the areas that you could easily improve and where they look outdated. So maybe in 20 years' time we'll look back at these two yachts and think they're outdated as well.
Hopefully. Or else the world will not have progressed. What's the biggest difference between 88 and 2010 for you?
That's a good question. I think just having a bit more time in the end to explore new technologies, and just a more open design book. In 88 we were limited to a keelboat and monohull, whereas this time we learned from those lessons and we're in a multi-hull.
As our design team director, I think it's fair to say, and I don't think I'm giving away any secrets here again, but you were perhaps the biggest proponent, aside maybe from Larry and Russell, but you were the guy who came to Larry and Russell and said, we got to do this way. We got to do this way. We've heard from the guys down the street who apparently considered doing it and said they didn't think it was worth the time or the energy or the harangue, weren't sure if they could do it. We weren't sure. I can remember a couple of meetings where some people said to you, Mike, have you gone and lost the plot here? But you really sold the project, didn't you? And how did that work?
Well, I really think that's overstating it a bit.
Go right up close so you can.
Yeah, I think that's overstating it a bit, Tom. I mean, these decisions are pretty big strategic decisions for a campaign and involve the input of many, many people, and because you need a wide variety of viewpoints, and the end product is a result of taking into consideration everybody's imagining of how hard it would be to build, to transport, to raise, to lower, to use, and so it's really a wide team decision. And in terms of just plain performance numbers, it's a pretty easy thing to say, hey, let's do a wing. But when you look at the scale of the guy on the drawing, it's a bit frightening. And fortunately, we ignored that for quite some time until we had to deal with actually rolling it out of the shed and raising it up. And touch wood, we've managed that so far.
How about the day that you rolled it out, we rolled it out, and you went sailing a couple hours later? How was your mental health that day?
It was no worse than normal, Tom.
Is Kaz Kelly here in the room?
Mike's partner, Kaz Kelly.
Sitting next to my son, Finn. I think the most stressful part of the whole operation is just lifting the wing around, because it's a wing. It never stops being a wing. It's never a brick. So any time it's hanging from a crane, it's a very, very nervous time.
Mark Sheffield from Great Britain. Thanks, Mike. A lot of talk the other day when Jimmy was here and talked about the heads-up display. And I think Pierre Orphanides and a couple others wrote extent. In fact, I think Pierre asked the question, and it really kind of took the press conference, then turned over to the heads-up display. Maybe you could tell us what, in fact, if you want to walk right up to the slide, please be our guest. Tell us what that's all about, and you and your colleagues, how you've pioneered this, and perhaps how important it has been.
Well, it started off back as a weight-saving exercise to try and minimise the weight on board. The start streams were pretty heavy, and the cabling on a 90-foot craft is quite long. So we talked to Jimmy about would he be able to look at a heads-up display, and this is actually a NED. It's a near-eye display system. So we call it NED, and Jimmy took some time to get used to it and integrated it into his glasses, as he told us yesterday. And Hoss has written all the software to go with it, and it's a pretty detailed bit of kit. So we can run any form of digital output from the computer onto the screen, and this allows Jimmy to have start screen data, load data, or any of the performance data as we're sailing.
So who did the hardware and who did the software?
The hardware is from an American hardware company, a visualization specialist, and Hoss has done our software.
So who wants to talk about the hardware? Eduardo or?
I think Mark really had firm command on this one, and I think this is for both of them, not me really.
Well, what would you like to comment about?
Well, I think I'd like to, one of the things I'd like to comment is we've been mentioning quite a lot the fact that the wing is a pretty phenomenal instrument. And one of the things that we found out while we were working with it is that in fact it's not only capable of generating a lot of power, we found out that it had a lot of other interesting features. And as we collected into the boat, we found out that quite a number of our sensors suddenly were quite unhappy about it. And we investigated it for a while. It took some time to try to find and understand what was going on. And essentially the wing is also a phenomenally good antenna. And we're picking up some of the local AM stations. And I think it could be quite an entertaining thing to listen to when there's no wind and with a bit bored in the boat.
Just hope it's not a lightning rod, too.
Well, fingers crossed for that.
What are the black spots? We heard Cam Lewis commenting about that yesterday on the telecast. Can we talk about the black dots on the leading edge of the wing? Who would talk about that?
Well, I think, I can talk about that. The black spots themselves are actually holes. They're not as, I guess, luckily have not been as useful as we thought. In fact, those are just access points. And in fact, what they are giving us access to is a number of tubes on the leading edge of the wing, which are what gives us the information we need to be able to know if the sail's properly trimmed. It gives us information on the angle of attack of the wing, of the apparent wind at different heights, and all this information also leads us to be able to calculate the lift coefficient. So that's in essence a wing. It's not as easy to trim as a normal sail. You can't tell that the wing is luffing in the front, so we needed to come up with something that would allow us to trim it properly.
Jose Luis, what's your role in the team? And tell us about what your day is like, because I know how busy all of you involved in the electron department are on each and every day and on the days off.
Yeah, basically my role in the team with my friend Javier is to code all the software that all the hardware that these guys produce is working on the boat. And it's from the sensor that Mark and Eduardo put in the boat, we try to read these measurements and put in the software and try to show to the crew in a way that is useful for trim and to get the best performance for the boat.
And Javier, maybe we can get you to join us here. Come on, don't be shy. You want to add to that? Right up here next. You want to add to that? You guys are being very modest, because I know I get my radio from you at dark 30 in the morning, and I know that everybody is pestering you all day, every day to do some little thing. Plus, you've got these big projects to work on. What are the? Can you just delineate the big projects that you have to deal with each day without giving away any drummer's secrets?
Well, as Ross has said, we are working in the instruments on the boat, so there is a lot of hardware and a lot of software. So I'm dealing more or less with the hardware for a bit, so I need to go on the boat and be sure that all the sensors are sending information and they are all working. And Jose is more working in the tactical and mathematical models, because there's plenty of real-time models working on the boat. And so basically in the morning what we have to do is I need to verify that everything is working. And when it's done and the boat is in perfect condition, then all the weight goes to Jose. Jose is going on the tender, and he's just taking care of the navigator. The navigator is happy, and the navigator shows something close to Jose, and Jose is looking remotely and just tuning the numbers or changing the things real time, and just be sure that everything is working in real time.
Mike Drummond, thank you. Thanks very much. Is this fair to say this is the most technically complex yacht, certainly from an electronic standpoint, that's ever been built, a racing yacht, or is that an overstatement?
Well, I can't really speak for other yachts, but in what I've been involved with, it's certainly it's a huge step forward in terms of the quality of the instrumentation, the accuracy, the repeatability of calibrations, all those things that make up the performance data for the boat and the tactical data. And these guys haven't evolved an existing system so much as just taken a huge step forward in my view, and it's been a big part of what we've been able to do. We launched the wing quite late, and we've managed to get it up and running pretty quickly to a high level of performance, and it's largely due to the effort gone into the various sensors, the software, and as well as the design predictions.
Mark, it's not new in the America's Cup to have a jumper on the yacht and then jump off with the cases, and that happened yesterday. The race committee was not ready for that. On the race committee